Okay, today we're going to be looking at geometric sequences. Very similar to arithmetic sequences. The only difference is that the pattern is going to be multiplication instead of addition. So for example, an arithmetic sequence might go 3, 5, 7, 9, 11, etc. A geometric sequence, on the other hand, may start with 3, but then go to 6, 12, 24, 48, etc. The difference here is that in arithmetic sequence, you're adding a number. In this case, we're adding 2 each time. In a geometric sequence, you're multiplying by a number. See, we're multiplying by 2 each time. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 4 times 2 is 48. Okay, so you can see the difference between an arithmetic and geometric sequence. Just like how we were able to write a formula to represent our arithmetic sequences, we are also able to write a formula to represent our geometric sequences. The formula for our geometric sequence is as follows. an is equal to a1 times r to the n minus 1, where a1 is the first term, r is the common ratio. You can find the common ratio by taking a term and dividing by the previous term. I will typically do the second term divided by the first term. That just makes it a little bit easier for everybody. Second term divided by the first term. an is some specified term based on what n is. So n is the term number or the number of terms. So if n is 5, then an is a5, which is the fifth term. Okay, so an is based on n, depends on what term you're looking for. To use this, let's take a look at a few examples. So number 1 says write a rule/model, tells us that a1 is equal to 2400, r is equal to 1 over 4, and then it says find a7. So what information do we have here? We have the first term, which is 2400. We have the common ratio, which is 1 over 4. We know that we're looking for the 7th term, which means that n is equal to 7. So what you always want to do when you start any problem, just like when we did the arithmetic sequences, same thing with geometric sequence, you start the problem by writing the formula. So if the formula is different in this case, it's a1 times r to the n minus 1. Okay, to write the formula, you need two things. You need the first term, and you need the ratio. So I can replace the first term. So I have an equals the first term, 2400, times the ratio, 1 over 4, to the n minus 1 power. This is the formula for the sequence. Okay, this is the formula for this specific sequence. I can use this formula to find any term in the sequence. The problem asked me for the 7th term, so I'll use this to find the 7th term. 2400 times 1 over 4 to the 7 minus 1. Okay, so that's 2400 times 1 over 4 to the 6th power. That's 2400 times, let's see, 4 to the 6th power. So 1 to the 6th power is 1. 4 to the 6th power is 4096. 2400 times 1 over 4096 is 2400 over 4096. 2400 is divisible by 32, and so is 4096. Okay, so I can simplify both of those by dividing by 32. So 2400 divided by 32 is 75. 4096 divided by 32 is 128. So this simplifies to 75 over 128. So that's our 7th term, 75 over 128. And that's what we were looking for. So that's our 7th term, and we're good. All right, let's take a look at problem number 2. It says find an. an is some term. We don't know what term it is until we know what n is. But we do know what n is. It's 8. So we're looking for the 8th term. First term is -4. The common ratio is -2. So we got first term is -4. Common ratio -2. We're looking for the 8th term. So n is equal to 8. As always, we start by writing the formula for this sequence. The formula an equals a1 times r to the n minus 1. To write the formula, we replace a1 and r. So we have a1 is equal to an is equal to a1, which is -4, times r, which is -2, to the n minus 1. So this is the formula for the series, or the sequence. This is the formula for the sequence. You can use this formula to find any term in the sequence. I want to use this to find the 8th term. A8 is equal to -4 times -2 to the 8 minus 1. Okay, so that's -4 times -2 to the 7th. Well, -2 to the 7th, what is that? -128, so this is -4 times -128, which is 512. So A8 is equal to 512, and that's what I was looking for here. Find AN. Well, AN in this example is A8, which is 512. Number 3, write a rule for the sequence, then find A9. Okay, so the sequence is given to us. We know that it's 3, 12, 48, etc. We know that the first term here is 3. Common ratio can be found by the second term divided by the first term. So 12 divided by 3, which is 4. And we're looking for A9, which means that n is 9. I'll start by writing my formula and then use the formula to determine the 9th term. So the formula an equals a1 times r to the n minus 1. I need to replace a1 with 3 and r with 4. So I have an equals 3 times 4 to the n minus 1. All right, well remember I'm looking for the 9th term, n equals 9. A9 equals 3 times 4 to the 9 minus 1. That's 3 times 4 to the 8th. So that's 3 times whatever 4 to the 8th is, 65,536. Multiplying that by 3, 196,608. Okay, so pretty big term here. Oh well, big number, but it is what it is. The 9th term is 196,608. Write a rule for the sequence. We had it. A9, we found that. And number 4, find the 10th term of the sequence. Well, same thing. We need to write the formula, which means we need the first term, which is 10, and we need the ratio, which is the second term divided by the first term, so 5 divided by 10. Don't put 0.5, write it as a fraction. This is 1/2. And remember, we're looking for the 10th term, so when n equals 10. Okay, so I'll write my formula. So my formula will always be in this form. I just need to replace the a1 and the r. So my formula becomes an equals 10 times r, which is 1/2 to the n minus 1. Now this is my generalized formula. It can be used to find any term. I want to use this to find the 10th term. A10 is equal to 10 times 1/2 to the 10 minus 1. 10 times 1/2 to the 9th. So that's 10 times 1/2 to the 9th. That's 1 to the 9th, which is 1 over 2 to the 9th, which is 5/12. So that's 10 over 5/12. Both of these are divisible by 2. Okay, so that divide the top and bottom by 2. That gives me 5 over 256. So my 10th term here, 5 over 256.